this is going to be a review of chapters 7 through 9. So your third test is on those 3 chapters. We've done a lot of problems in this chapter, so I'd go back and review like your discussion questions and your quizzes and so on. Remember, formula mass is how much a compound weighs. So if I'm trying to find the mass of this, I'd take 1 copper, 2 chlorine, and add them together. Okay, so this would be 63.5 and 2 chlorine would be 71. You add them together. So again, when you're doing formula mass, you guys, it's just the individual elements, how much of each multiplied by their mass from the periodic table. This would be 2 sodium, 1 phosphorus, and 4 oxygen, and add them together. Okay. 1 barium, 1 carbon, 3 oxygen, add them together. And you guys can practice these if you want. I've got the right answer here. Remember, if something's in parentheses, like here would be 2 aluminum. This would be 3 sulfur. You don't multiply the 3 by the aluminum. It's 3 sulfur and 12 oxygen. Okay. So make sure if something's in parentheses, you multiply everything inside. And again, you can go back and double check on these. I have the right answer just to practice. Here's some more. This one would be 2 iron and 3 oxygen. This would be 2 nitrogen, 8 hydrogen, and 1 sulfur. 1 silver, 1 nitrogen, 3 oxygen. And then this would be 3 iron, 2 phosphorus, and 8 oxygen. Okay, just add them all together and get your mass. Okay. All right, percent composition is where you take the individual element divided by the total. So if I'm doing magnesium carbonate, first I'm going to find the mass of magnesium carbonate. Okay, so 1 magnesium, 1 carbon, and 3 oxygen, when you add them together, weighs 84. Okay, well, magnesium is just 24, so 24 divided by 84 would be 0.286 or 28.6%. For carbon, I'm going to go 12 divided by 84. Okay, and for oxygen, again, it's not 16 because there's 3 of them, so 3 times 16 is 48, so 48 divided by. So you take the individual divided by the total, and your percent should be close to 100. Again, if you get 99.9 or 100.1, that's okay, but if you get like 102, that's not so good. You messed up somewhere. Okay, so again, find the mass of it. The mass of that H2SO4 is 98. So for hydrogen, I'm going to take, because there's 2 of them, 2 divided by 98. For sulfur, 32 divided by 98. And for oxygen, 64 divided by 98. So when you do percent composition, it's the individual divided by the total. Okay, simplest formula. Remember, this is just the opposite. You get the percentages. So the first thing you got to do is take the percent they give you. In this 70% iron, so I'm going to take 70 and I'm going to divide by iron's mass from the periodic table, which is 56. I want to find the number of moles. And then for oxygen, I'm going to go 30 divided by 6. So you're going to get the moles right here. Once you get the moles, what you do is you set up a ratio. The smallest number in the bottom, 1.25, divided by each individual. So this is going to be 1, and that one equals 1.5. So again, remember, when you don't get a whole number, if it was 1.97, you guys could divide, you could round it to 2, but it's not. It's too much in the middle. So what I'm going to do is double each of these. I'm going to make this 2 and this 3. So my empirical formula would be Fe2O3. Okay. So when you're doing the simplest formula or the empirical formula, take the amount they give you. Sometimes it's in grams, sometimes in percent. It doesn't matter. You solve them exactly the same way. Take the amount they give you, divide by its mass from the periodic table. That'll give you your moles. Okay. And then set up your ratio with the smallest number on the bottom. Okay. How many moles and 456 grams of carbon dioxide? Okay. Write down what you know. 456 grams of carbon dioxide. Then 1 mole on top and whatever the mass of carbon dioxide is. Okay. So write down what you know. 456 grams of CO2. I got to get rid of grams and I need moles. So I'm going to put 1 mole here. And if I take the mass of 1 carbon and 2 oxygen added together, I get 44. So this is a conversion factor. It's just like multiplying by 1. Because 1 mole of carbon dioxide has a mass of 44. Okay, so anytime you're converting, you got to find the formula mass of that compound, and that's what 1 mole weighs. So I'm just going to take this divided by this, and I get 10.36 moles. So in 456 grams of carbon dioxide, that's 10.36 moles. Okay, and these are the conversions we did in that last chapter, chapter 9 in stoichiometry. But this is just the conversion. In chapter 9, we take these conversions and add them to other conversions to get answers. Okay. how many grams and 5.36 moles of barium hydroxide. Okay, so now you write down your moles, 5.36. Okay, now I'm going to have moles on the bottom. So I'm going to put 1 mole, and if I take 1 barium and 2 oxygen and 2 hydrogen and add it together, I get 171. That's the mass of this. So I take this times this, okay? So again, if you're wondering how to set them up, whatever you start with goes on the bottom. Whatever you start with goes on the bottom, okay? So that's how you know. In this case, I'm going to multiply them. So 5.36 moles of barium hydroxide is 956.56 grams. Okay, here now we have to find the simplest formula and the molecular formula. So again, we're going to take carbon, 37.6, and divide by 12. That's its mass from the periodic table. Its mole ratio is 3.13. We'll do the same thing with hydrogen, 12.5. Good thing hydrogen's 1, right? It's 12.5. And oxygen, 49.9 divided by 16 is 3.11. So now I got my moles, my number of moles, okay? Then what I'm going to do is set it up so the smallest number's on the bottom, well, 3.11. When I divide these, I get 1. What do you think that is? 4 and 1. 1 to 4 to 1, okay? So my formula is CH4O. Just put those numbers in there. Okay, now it says its molecular mass is 128. So what's its molecular formula? So this is its simplest formula. So what I'm going to do now is I'm going to find the mass of this. 12 plus 4 plus 16 is 30, I think, right? 12 plus 4 is 16, and 32, sorry. So that's the formula mass of this, 32. So I'm going to take 128 divided by 32, and I get 4. So basically, I'm taking everything in here times 4. Okay, so it'd be C4H16O4. Okay, so when you have to do molecular mass, all you have to do is one more step after you find the simplest formula, find its mass. And again, that's 32. Take what the mass they give you, 128, divide by 32. You're going to get a whole number. So multiply everything by that number. That's how you do molecular formulas. Okay. Balancing equations and tell me what type they are. This is chapter 8. I didn't balance them, so I'll tell you what type they are. You can go back and balance them. This one, you start with 2, end with 2, so you know it's single or double. Got 2 compounds, 2 new compounds, it's double. Oops, sorry. This one, carbon dioxide and water, combustion. Okay, here, start with 2, end with 2, so it's single or double. I got an element by itself, so it's got to be single. Okay, here I start with 1 compound and I break it down into 2. Okay, so if I break it down, that means it's decomposed. That's decomposition. And here I have 2 things and they combine to form 1. That would be synthesis. I made something. Okay, so these 2 are just the opposite. So I have 1 and I break it down into 2. That's decomposition. I have 2 and they combine. That's synthesis. Okay, the other one's 2 and 2, 2 and 2. Look for carbon dioxide, water, combustion. On the other ones, element by itself, elements by itself, single. Here, there's no elements by itself, double. Okay. Here, again, you'll have to balance them, but I got 1, 2, and I end up with 3. So I started with 2 things and I broke it down into 3. That's decomposition. Carbon dioxide, water, combustion. 2 and 2, so it's single or double. Element by itself, element by itself. So that's got to be single replacement. Here I have 1 substance and I break it down into 2. That would be decomposition. And here, the magical carbon dioxide and water. Okay, so carbon dioxide and water, that's combustion. When you're balancing a combustion equation, you guys, those are usually the toughest to balance. Okay, first thing, balance your carbon. So I put a 4 here for my carbon. I'd put a 5 here to balance my hydrogen. Now I got a problem because I got an odd number. With a 4 here, I got 8 here and 5 here. That's 13. There's no way I can get 13 over here because I have to use whole numbers. So if that happens, double the first one. Put a 2 here, so I'd put an 8 here and a 10 here. Now 8 times 2 is 16 plus 10, that's 26. Then I'd put a 13 here. So anytime you're doing a combustion, do carbon first, hydrogen next. If you end up with an odd number over here of oxygen and even here, double the first one, and then it's easy to balance, okay? Those are probably the trickiest ones. The rest of them aren't too bad. Make sure you know how to balance equations, you guys. It's really important in chemistry. We have some. Go back and look at some of the stuff we've done. There's a PowerPoint where you practice doing them. Go ahead and redo that. Okay, using the following equation, all right, we have a balanced equation. When you have 186 grams of hydrogen, how many grams of HCl can you produce? So this is stoichiometry. Write down what you know, 186, 1 mole on top. The 2 is hydrogen. Hydrogen, each one is 1, and there's 2 of them. So this is his formula mass. So I got rid of grams, and I got moles. Now I put moles of what I'm trying to find on the bottom, or get rid of on the bottom, moles of what I'm trying to find on top, sorry. This is where I use my balanced equation. The 2 here, and a 1 here. And then my last step, 1 mole of HCl has a mass of 36 grams. So again, remember, this is the only time you use the balanced equation. Don't use it over here or here. These are just conversions. So you take 186 times 2 times 36.5 and then divide by 2. And that's your answer. Okay? These are stoichiometry problems. This would be a mass to mass. Okay, here we got a balanced equation. When you have 4.5 moles of aluminum oxide, how many grams of CaOH? Again, these ones, I just put the answers. These are for you to try. There's another one. Okay, and again, I'll have this PowerPoint on there without me talking, so you can go back and look at it. Okay, and again, how many atoms in 5.3? If you're going to do this, you guys, 5.3, 1 mole in the bottom, Avogadro's number on top. Again, I have the answer here. These are for you to work on, okay, to practice. You've got the right answer so you can see if you're doing it right. Okay? So that's the end of that. Make sure you go through it and get ready for your test. Good luck. And email me if you have any questions. And remember, we have Rayanne and we have Philip to help you if you need tutoring.